So we know how to store 100 ages in an array as ints. We can write int ages 100, and that allocates room for 100 ints. And then we can store the age of an 18-year-old by writing ages 0 in our first index equals 18. But what if we don't know how many ages we'll need to store? What if it's not 100? What if it's whatever the user enters into our program earlier? It could be any number of ages. One option would be to allocate room for more ints than we would ever need, so we could write int ages 10,000. But you can see an obvious problem with that immediately, and that's that memory is limited. And if we allocate 10,000 ints and only use 3, that's a bit of a waste. So we need some way to dynamically allocate memory, and that's where the malloc function comes in. You tell malloc how many bytes of memory you need, and malloc will try to find it for you, and it'll usually succeed. So this is what malloc looks like. You'll see it takes just one argument, size, and that's the number of bytes you want from it. So if we want to store an array of 10 ints, ints being 4 bytes each, we'd malloc 40 bytes. And you see here it returns a pointer, and that's a pointer to the start of the memory block it's allocated for you. It's important to check that's not null, because if it is, malloc has failed. So we could assign that pointer to an array like this, int star ages malloc equals malloc 40. So malloc will return a pointer to a block of 40 bytes of memory, and our ages malloc variable will point to that. So we have our array that's 10 ints big, and if we want to store something in it, we do it just like any other array. Ages malloc at our first index equals 19. So let's test our mallocing and make sure it's worked. So this should just print out what we stored in our malloc's first index here, a 19-year-old. There you go. At index 0, ages malloc is stored at 19. So that's how malloc works, briefly.